In the highest latitudes of the north, the sun eventually disappears for months. This is the polar night, a period where the landscape is locked in a blue-tinted shadow and the snow sparkles only under the light of the stars. Early observers, like the explorers seen here with their primitive camera equipment, stood in this freezing stillness without the benefit of modern sensors. They were forced to reconcile the dark, silent landscape with an expansive, glowing sky they couldn't yet explain. Humans have a psychological drive to find patterns in their environment. Lacking atmospheric data, the people living under these lights developed powerful mythologies to give the phenomenon a name and a purpose. One ancient myth describes the fire fox. The legend tells of a spectral creature running across the frozen mountain peaks, its heavy tail kicking up sparks as it brushes against the deep snow. According to the story, these sparks drifted into the atmosphere to ignite the broad, waving curtains of color that dominate the night. While the myth is a striking explanation for the cold, the actual scientific mechanism is far more violent, and it originates from a source much larger than any terrestrial animal. The true catalyst for the Northern Lights begins 93 million miles away from the Arctic Circle. This image captures the sun's surface, where towering, explosive solar flares erupt into the vacuum. These events launch unimaginable volumes of energy into the solar system, providing the raw power required for the aurora. This stream is the solar wind. It is a continuous, high-speed river of charged particles thrown out from the sun, traveling millions of miles through space toward Earth. When this invisible energy strikes our planet, it collides with the magnetic shield protecting us. Our magnetic field channels these particles toward the poles, where they can finally penetrate the upper atmosphere. In this way, the invisible energy of a distant star becomes the brush that paints the polar sky. Back on the ground, we see the result as wide, sweeping bands of green light. These colors are specific chemical signatures, providing a real-time report on the composition of our air. These specific colors act as elemental fingerprints. They tell us exactly which gases are reacting with the solar wind miles above the surface. Oxygen is the primary source of the most common displays. When solar particles excite oxygen atoms in the atmosphere, those atoms release energy in the form of these characteristic green hues. Nitrogen produces a different wavelength. When the solar wind strikes nitrogen molecules, it triggers rarer reactions that appear as pink or purple light. We can see these nitrogen reactions in this photograph. Here, the sky is filled with vivid purple and pink clouds, indicating a high-energy collision with nitrogen in the upper atmosphere. By learning to properly read these distinct colors, anyone looking up at the night sky is observing a color-coded map of the gases that protect our planet. In the deepest parts of the winter, the Arctic is a place of absolute stillness and profound silence. Because the light show happens so far above us, the aurora is often characterized as a purely visual experience. However, travelers in the most isolated regions have documented a strange phenomenon. During the brightest displays, the Arctic silence breaks. Observers report hearing tiny pops and static hisses and distinct crackling sounds. These unexpected noises are not coming from the sky above, but from the air immediately surrounding the observer. This is the result of immense electrical charges. The solar energy interacting with our atmosphere creates static fields closer to the ground, which eventually discharge as audible crackles in the dry, freezing air. The Northern Lights are a multi-sensory connection between our world and the sun. They prove that even in the most isolated corners of our planet, we are chemically and audibly linked to the physics of the cosmos.